All right, so this is going to be a little bit of a conversation on the cardiac cycle. So, in regards to cardiac cycle, we want to consider ventricular pressures and ventricular volume. So, we're going to start with systole. So, systole and diastole here, we're talking about the ventricles, and more specifically here, we're going to talk about the left ventricle. So, notice that each systole and each diastole will start with something that's isovolumetric. And for the systole, that's going to be isovolumetric contraction. And that contraction, isovolumetric contraction, will have this high volume in the ventricle. For the diastole, it's going to have a low volume, right? So in the systole, we have isovolumetric contraction, because for this split second, it's going to have all of the valves, so the aortic valve and your mitral valve will be closed. That allows to maintain that same volume. However, the pressure in the chamber of the ventricle will increase because ventricle will be collapsing, and as it's collapsing, the pressure in the ventricle will increase. So as it continues to increase and reaches the aortic pressure, that's going to cause the opening of the aortic valve. With the opening of the aortic valve, you will have your blood from the ventricle leave the ventricle into the aorta, and that's going to have a rapid ejection. And then at some point, you will start decreasing in your ventricular pressure as you lose the ventricular blood. So then your systole will end at a point where your aortic valve closes. So as your aortic valve closes, you're gonna end your systole. Let's get this out of the way. Okay, perfect. So then again, we are going to start a diastole. And our diastole, as we know, is going to start with isovolumetric relaxation. So we're going to have a low volume in the ventricle, and it's going to be the same for a split second because, again, your aortic valve will be closed as well as your atrioventricular, the mitral valve will be closed. But then at some point, you will have the mitral valve open. So as your mitral valve will open, you will get this ejection, rapid filling of the blood from the atria into the ventricle. So you will get that left atria blood flowing into the left ventricle, and then here at this moment you will start having this atrial contraction to get this last kick of the volume of blood into the ventricle, which is going to give this a little bit of a rise in the blood volume in your left ventricle. All right, and then at that point, you will have your AV valve, the mitral valve, close. So as you close your valve, that's going to mark the end of the diastole. So I have the maximum volume of your ventricles of blood in the ventricles. All right, so just a quick recap. So we know that each systole and each diastole will start with isovolumetric situation. If it's systole, it's going to be isovolumetric contraction because both valves will be closed. If it's diastole, it's going to be isovolumetric relaxation and the volume will be low. Then the other important aspect is that each systole will end with the aortic valve closing, and each diastole will end in your AV valve closing. And then in the systole, which is your contraction, you will get this ejection of the blood into the aorta. And then in the diastole, you will have a rapid filling of your of the blood into the into the ventricle, and also you'll get this final kick of the atrial contraction. Alright, so that was a quick recap of a cardiac cycle.